Hello out there. Purpose of today's video lesson is to find out how we can find the equation of any line if we just know two things. Any 2 points on the line. That's all we need. If we just have 2 points on a line, we can find the equation of the line. In fact, we can probably find the equation of the line if we know the slope of the line and just one other point as well. But to begin, I'm going to explore a little bit because we just got done studying direct proportion, and this particular equation is the function equation that represents a direct proportion. As you may or may not recall, this one dealt with the cost of buying rope, where it was 8 feet of rope would cost an additional $3, or 3/8 of a dollar per foot. So as you can see, we have $0 for 0 feet, but if we had 8 feet of rope, it would be $3. And if we had 16 feet of rope, it would be $6. There's another point on the line. And we can even use fractions for 4 feet for $1.50, or for 1 foot, it would be $3.25, or 32 cents, something like that. Anyway, the line that I have down here, though, looks exactly the same as this line. The only difference is it doesn't go through the same points. You see, this is 16.6, and this one goes through the point 16.9. So it appears as though this line has drifted away from its original home at the origin. So I'm going to try to figure out how to find the equation of this line. And the first thing I'm going to do is consider the fact that the slope of the line is the same as the slope for my direct proportion that started at the origin. So if I take the point 16.9, using the slope 3/8, I would go up 3 after I went over 8, and I end up at a point 24.12. So I know that 24.12 is one of the points on this line, so 24.12 will also be a solution to whatever equation it is that I find. But the real significance here is that the slope 3/8 should have to factor into the equation somehow. The other perspective I'm taking is it appears as though this line has shifted away from its original home. So if I was to take this line and to literally walk it home, I would have to drop the line down 9, so the y values would have to drop 9, and the x's, I would send that back 16, so that the point 16.9 has been shifted back home to the origin. Well, just to see what happens, I'm noticing that if I did y minus 9, that's moving the line down the 9 right here, and then 3/8 x minus 16, that's moving the x's back 16. I wonder if this would be the equation, or an equation of the line. Well, one way to find out for sure would be to put the value 16.9 as a solution to the equation. So y is 9, so I have 9 minus 9 equals 3/8. The x is 16 minus 16. Of course, I end up with 3/8 of 0, which is in fact 0. Well, it kind of seems trivial, and it's almost like I just got lucky or something. Of course, 0 equals 0. That doesn't mean this is the equation of the line. But if this is the equation of the line, then all of the other points on this line should also be a solution to that equation. So let me try at the point 24.12. If I put in y equals 12, so it'll be 12 minus 9 equals 3/8 of 24 minus 16. Well, 12 minus 9 is 3, and then I have 3/8 of the difference between 24 and 16, which is 8. And of course, that went fast. 3/8 of 8 is 3, so 3 equals 3. Then this is also a solution to that equation, so this must be the equation of that line. But I was thinking to myself, which is dangerous, that what if I used this point and said, the line also drifted away from its original point, the point 24.12 instead, which means to find the equation of the line, I could move this down 12 and back 24. Which is why I wrote this equation, y down 12 equals 3/8, the original slope, times x back 24. I'm wondering, would this also be an equation of the line? Again, I'm going to take the point 16.9, which is one of the points on the line, should be making this equation true. 9 minus 12 equals 3/8 times 16 minus 24. And 9 minus 12 is negative 3. 16 minus 24 is negative 8. Ooh, and sure enough, 3/8 times negative 8 would be equal to negative 3. So I guess what I've just noticed is this is one equation of the line, and this is another equation of the line, and there are, in fact, infinity points on this line, so I could use any method I want, or any point that I want to, as long as I keep the slope the same. If I found any point on this line, I could use the coordinates of that point and just walk it home to the origin, and I would have the equation of the line just like that. I think that's what this is. But I'm noticing, though, that these equations look different, and I don't like the fact that they look different, but give me the equation of the same exact line. So I'm wondering if maybe if I do a little bit of algebra here, I'm going to distribute the 3/8. So 3/8 of x and 3/8 of 16 is 6. Then I'm going to add the 9 to both sides and get 3/8 x plus 3. I'm going to take the other equation, this guy. I'm going to do the same thing. I'm going to distribute the 3/8. So 3/8 of 24 is 9. And I'm going to add 12 to both sides, and we get the same equation. So here, not only do I find that no matter which point I use, I get the same line, but if I was to solve these equations for the y variable, I would get the slope-intercept form that we looked at earlier. Moreover, if I extended this line back to the origin, sure enough, the y-intercept is 3, just as indicated by here when x is 0, y is going to be equal to 3. So it appears to me that, I just want to make sure I got this right, if I have the slope of a line and any point on the line, that I can just walk that line back to the origin and that would give me the equation. So I have this structure, I write that down, and then I do y plus, well, let's see, from here I have to go up 2 and back 4. So I'm going to add 2 to the y's, and I am going to subtract 4 from the x's to get back to the origin. I noticed something while I was doing this. The point that I was working with was 4, -2, but the coordinates in my equation are +2 and -4. So this is opposite of what the actual y value is, because I had to go up that much, and this is the opposite of what the x value was, because I had to go back that much, which must be why this formula always has -y1 and -x1, because we're going to take the opposite of the coordinates of each of those points, and that's what's required to walk back to the origin. I don't usually think about this because it's an extra step in my head, but I like the structure. I want to keep that structure in my head for sure. So I ask you guys when you do this work to write that structure down, but then when it comes to getting the equation, just walk up and over, and that will give you the right values, 2 and -4. Then you don't have to worry about screwing up your negatives. Distribute the slope and subtract the 2 from both sides. Then you can go back over to this line and verify that is in fact the y-intercept is 4. Moreover, there's another point down here at 6, -5. So you can very quickly say at 6, -5, let's see if this equation makes that true. We're going to have y equals 6 equals -3/2 of, oops, the y was -5, dummy. 3/2 times 6, and then add 4. If we take -1.5 of 6, that would be -9 plus 4 is indeed -5. So apparently all I have to do to find the equation of a line is I have to know the slope of the line, and I have to know one of the points on the line, and I can walk it backwards and get what I need. Now, I just want to talk about that structure for a little bit because I noticed something interesting while I was playing around with this. I remember solving equations like this. We would do what's called fraction busting. I would multiply both sides by 3, and the 3's divide out over here, and we get x equals 12. Of course, that's right. You can see that 12 divided by 3 equals 4. Of course, I didn't need to use sophisticated algebra to figure out a number divided by 3 equals 4. That number is 12. But it's the structure that I find interesting because I don't even have to know what numbers I'm talking about. If I have the equation a over b, a divided by b is equal to c, and I wanted to know the value of a that makes this equation true, well, I'm just multiply both sides by b, and I get a equals c times b. And for the same reason, if I do c times b over b, that equals c. So, in other words, I don't even have to know what numbers I'm talking about for the structure of algebra to hold. I can rearrange any equation by using multiplication and division to get rid of certain numbers, divide them out to be 1, so to speak. Well, when we were studying slope, we learned that the change in y over change in x is equal to slope. So if I multiply both sides of this equation by change in x, these should divide out to 1, and I end up with the equation change in y equals slope times change in x. That's just ringing a bell for some reason, but I remember how did I find the change in y? I subtracted 2 y values. How did I find the change in x? I subtracted 2 x values. So couldn't I use the same thing and multiply both sides by x minus x1 and end up with this? Holy cow, this is the same formulation that we were just looking at over here. It's the same form. So the basis or origin of this formula is just the slope formula. We just rearrange the slope formula and we get this new formula, which is called the point slope formula, because x1 and y1 represent the coordinates of a point and m represents the slope. So if we want to use this formula, we need to know a point, x1, y1, and the slope. So we call it the point slope formula. Rocket science. Here's a quick another review. Here I have a line whose slope is 1/2 and it goes through the point 3, 3.5. Well, then I would walk this down 3.5, so y minus 3.5, and then the slope is 1/2 times x. I'm going to walk that back 3, so I'm going to write the minus 3, and then when I do my cosmetics, I end up with y equals 1/2 x plus 2. I observe that the y-intercept is 2, and then I take another point on the line and I can check it. So this is a synopsis of all the steps you should follow, just to make sure that not only are you getting the right answer, but you're getting something that's comprehensible, something that you understand. So the first thing you should do, if you're finding the equation of the line, you should definitely graph the line. If you find the equation of the line without graphing, then you're just playing blind, and it's just not smart. The nice thing about the graph is we can estimate what the slope and the y-intercept are just by looking at it and counting back to the y-intercept. You use your estimates to predict what the equation of the line should be, and you calculate the slope if you don't already have it. Walk the point home using the point slope formula, and then simplify. Use one other point to determine you're correct. So if you follow all of these steps, you'll have a complete set of, demonstrated understandings of linear equation finding. So there is a line that has a slope of -1 and goes to the point -612. Here's the point -612. I plot that point. The slope is -1, so I'm just going to go down 1 over 1, or I could go down 4 over 4. Anything that I do for y change, I should do the same for the change in x to get that slope. So I got another point using my counting methods. I got the point -2.8. And I also found out that the y-intercept is going to be 6. To find the equation of the line, all I have to do is put the slope where the slope belongs, but then I also have to take this point and walk it home. So I'm going to go down 12 and then over 6. So that's y down 12 equals slope times x right 6. So we have y minus 12 equals -x minus 6, I distribute, and then we get y equals -x plus 6, which matches the y-intercept. So I go through here. I can check by using another point that I found, -2.8, and that -2.8 is also a solution to the equation. That means this is correct. This is the equation of the line that represents this character, or these traits. If you don't already know the slope, then you're going to need at least one other point so that you can find it. So, for example, I have the point -3.5 and the point 1.12, so all I have to do is count from -3 over to 1 is 4, and then from 5 all the way up to 12, that's a change of 7. So I can guess that already the slope is going to be 7/4. And I could also see here, if I went over back 1, down 7/4, I would be at 10.25. So I can count back to figure out what the y-intercept should be. I can count over to see the slope. So I already know, before I start doing all my fancy math, I can already tell that the equation of this line is going to be y equals 7/4 x plus 10.25. But sometimes we don't always have numbers that work out so clean. So I just want to make sure that I get the process right, using the right structure, so that it's foolproof and I don't accidentally make some bonehead mistakes. So first I'm going to calculate the slope, and sure enough, when I do 12 minus 5 and 1 minus -3, I get 7/4. No surprise. Using this structure, I always write that down to remember it. We're going to drop the point down 5, line down 5, and over 3, so that's y down 5 equals 7/4 plus x plus 3. Notice again, the point -3.5 appears in this equation as -5 and a 3 here, so everything's opposite. Doing my basic algebra, I end up with y equals 7/4 x plus 10.25, just as I expected. And over here, you can see I accidentally overwrote my stuff. Oh well, you can see it. I can put the point 1, -12, or sorry, I can put the point 112, which is the other point. I didn't use the point 112 to get my equation. I can use the other point that was given as my checkpoint. So when x is 1 and y is 12, is the equation true? Well, 7 quarters plus 10 1/4, yes, that does equal 12. So I win all my points. So that went a little long, but should cover not just what the process is for finding the equation of the line, but why. So practice this and master it, because it's a skill that's used all the way through your mathematics education. Thanks for watching. Have a good day.